Hello everyone, welcome back. Here in this video we will start 5th unit of our strength of materials, which is principal stresses and strains, and also we are having theories of failures, which we will cover in our next coming classes. Before we talk about the concept of principal stresses and strains, let us see a simple member subjected to different loads. Due to the action of these external forces, there is an internal resistance developed in the member. To find these internally developed forces, I will just consider a cross section in a member. If we see this cross section, the internal forces developed in the body due to these external forces are derived into two components, a horizontal component and a vertical component, where this horizontal component is the tangential stress and the vertical component is the normal stress. Like in this case, if we consider any oblique section in the member, that oblique section is only subjected to normal forces. There are no shear forces or tangential forces on the member. Such planes which are having only normal stresses, those planes are called principal planes, and the stress which is acting on that plane is called principal stress. So let's see the definition of this. Principal plane, the planes which has only normal stress and no shear stress are known as principal planes, and as well as the normal stress which is acting on the principal planes are known as principal stresses. These principal stresses are again derived into two types. See, one is major principal stress and the another one is minor principal stress. The plane carrying the maximum principal stress is called major principal plane, and the stress corresponding to that major principal plane is called as major principal stress. And in the same way, the plane carrying minimum normal stress is called as minor principal plane, and the stress corresponding to that minor principal plane is called as minor principal stress. To calculate these principal stresses and to locate the principal plane, first we need to calculate stresses which are acting in an oblique plane. So to find the stresses which are acting on an oblique plane, we have two different methods. The first one is analytical method, okay, and the second one is graphical method. In this analytical method, we will use the concepts of trigonometry and we will find the location of the principal planes and the stresses which are acting on that principal planes. And in these graphical methods, we will find principal stresses with the help of drawing, and also we will locate the location of principal planes with the help of drawing itself. First, we will discuss about these analytical methods, then we will go with these graphical methods. If we see this analytical method, it is divided into four different cases, where the case 4 is combination of all three, but for our easy convenience, we separated it into four parts. The first case is a member subjected to simple tensile force, and the second case is member subjected to simple tensile forces which are like and direct stresses perpendicular in nature, and the third one is member is subjected to pure shear, and in the last case a member is subjected to two direct stresses which are perpendicular to each other and accompanied by a shear stress. Let us solve these cases one by one in these coming videos. See you in next class. Thank you.